Welcome guys, we are going to look at the questions under the topic of current electricity. So we'll look at different questions from different past papers. So we have first question, figure 7.1 shows a 6.0 volts power supply connected to two resistors which are in parallel. Right, so we have two resistors and I'm going to call this one as resistor 1. Then this will be resistor 2. So what you're supposed to remember is whenever you are dealing with a connection in parallel, voltage must be equal to at each resistor. Now, before we look at voltage, let's have a look at the first question. So the first question is calculate the effective resistance. So effective resistance simply means the total resistance. So we can use this formula 1 divided by RT. So RT stands for total resistance is equal to 1 over R1 plus 1 over R2. So this is the formula. Since we only have two resistance, we just end at R2. Or we can go direct where we say RT is equal to resistor 1 times the resistor 2 divided by resistor 1 plus resistor 2. Now, to use this formula effectively, make sure you have two resistors. So I'm going to use this one because it's more direct than the first one. So I'm going to say total resistance is equal to resistor 1 is 4 ohms, resistor 2 is 12 ohms. So we're going to say 4 multiplied by a 12, then divided by 4 plus 12, which is RT is equal to, so if you multiply 4 times 12, we get 48 over the sum of the two numbers here, 4 and 12 will give us 16. Then 16 into 48 will just give us 3. So this simply means that if we combine the two resistors and make it 1, then the value will be 3 ohms. So we have our answer for the first question. So we move on to question B. Calculate the value of the current in the first one. We want to identify the current that was passing through the 4 ohms resistance. So in this route here, how much current is flowing through this? So I'm going to call this one as current 1. Now, for us to find current given voltage and resistance, we are going to apply the formula from Ohm's law. The formula is current, which is current 1, is equal to voltage divided by resistor, but I'll call this one resistor 1, so I want the numbers to match. Right, so now what is our voltage? Are we going to use 6.0 or maybe do we have to change some numbers? No. So what you have to know is the voltage that we are going to use is 6.0. Remember, voltage across each resistor, as long as they are connected in parallel, is equal. So the same voltage will be passing through resistor 1 and also resistor 2. So even on resistor 2, we are going to have 6.0. So to find our final answer, we can say, what's voltage? 6 divided by, what is resistor 1? We have 4 ohms. Then 6 divided by 4 will give us 1.5 amps. So this simply means that from a certain amount of current, 1.5 went through resistor 1. So that is our current 1, 1.5 amps. Then for the second one, Roman number 2, we want to find the current in the battery. So the current in the battery is same as the total current. So now how do we find the total current? So we are going to find current 2. So current 2 is equal to voltage divided by resistor 2. So what is voltage? on this resistor is still 6 over resistor 2 is 12 ohms. So 6 divided by 12 will give us 0.5 amps. So this is the current now in resistor 2. So 0.5 amps. Therefore, to find the total current, I can say IT is equal to resistor 1 plus resistor 2, which is resistor 1 is 1.5 plus 0.5, giving us 2 amps. So this was the total current. But the point is, when this current reached the junction of A, 1.5 went through resistor 1, 0.5 went through resistor 2. Then from this same point here, we can see that here resistor 1 is 4 ohms, resistor 2 is 12 ohms. Then from the smallest resistance, we had the greatest current. Therefore, the smaller the resistance, the higher the flow of current. That's why these two are inversely proportional. We can also find the total current by using this formula, the same formula, but we'll say IT is equal to voltage over total resistance. So voltage is still 6, total resistance we calculated to be 3. So 6 divided by 3, we still get 6. So you can go direct, but make sure when you are going direct, use the total resistance of the whole circuit. Right, so let's move on to the second question. Okay, so this question reads, figure B 8.1 shows 3 resistors connected to a 12 volts battery. Right, so I'm going to put numbers. I'll call this one as resistor 1, resistor 2, then resistor 3. Then if you look at resistor 2 and resistor 3, these two are connected in parallel. Then the effective resistance of the two, this will be now considered to be connected in series with resistor 1. So what do we mean by this? Let's look at the first question. So the first question is, they want us to find the effective resistance between X and Y. So we're going to say total resistance is equal to, so this is resistor 2 times resistor 3. Then divided by the sum of the two resistors, which is giving us resistor 2 is 12 times 6 over 12 plus 6. So if you punch this one, you get 6 times 12 is 72 over 18. Then 72 divided by 18, I'm getting 4. So 4 ohms is our total resistance for resistor 2 and resistor 3. So if I were to redraw, let me give you now the picture of now what has happened. So what has happened is these two have been combined to form one. So this is now our 4 ohms resistance. Then here we have our 2 ohms resistor. So let's call this one resistor 1, then resistor 2. So now to find the total resistance of the whole circuit, we can now treat the remaining as in series. So what do we do in series? In series is just a direct addition. So it's resistor 1, then plus resistor 2. So resistor 1 is 2 ohms plus 6 ohms, which is, should be 4 ohms, which is in total giving us 6 ohms as our final answer. Right, so let's move on to question B, the current flowing in the battery. So I said whenever they want the current in the battery, same as the total current of the whole circuit. So you need to say total current IT is equal to voltage produced by the source, then divided by total resistance. So here you need to make sure that you calculate the total resistance of the whole circuit. So voltage, we can see that the voltage is 12 volts over, what is our total resistance? We say it is 6. So 6 into 12 will give us 2 amps. So 2 amps is our total current. Now, if you look at this one, so this one is connected in a series. So what happens is, in this resistor 1, 2 amps of current was flowing through. But for resistor 2 and 3, the current, the 2 amps is divided. So there is a certain amount of current going through 12 ohms, another amount going through 6 ohms. But the two currents that are divided at the junction must sum up to the total current of 2 amps. Now let's look at the question C. The current are flowing through the 6 ohms resistance. So from that 2 amps, these 2 amps here, how much flew through the 6 ohms resistance? So what are we going to do? Let's look at how much voltage was consumed by a 2 ohms resistance. So voltage is equal to this. So voltage is equal to current multiplied by resistance. So what's our current here? Is 2 amps. This is connected in series, so current, you just have to use the total. Then resistance, since we want the voltage across 2 ohms, 2 ohms resistance, then we are supposed to use the 2, which is 2 times 2 is 4, which simply means that out of 12 volts, 4 volts is consumed by a 2 ohms resistance, which simply means that if at this point X there is 12 volts, then at this point we are going to have 8 volts because 4 volts has been consumed. Then since these two now are connected in parallel, 8 volts will go in this direction and also 8 volts will go in this direction, which is we can now find the current across the 6 ohms resistance. So current of R3 is equal to voltage divided by, sorry, let's not say current of R3. So let's call this one as current 3. So we'll say current 3 is equal to voltage divided by resistance 3. Voltage is 8 divided by 6. So 8 divided by 6, getting 1.333 carrying. So I'll just say 1.3 amps. So this is our final answer. Now to just prove, let's also calculate the current that was flowing through the 12 ohms resistance. So I'm going to use the same formula. So I'll call this one as my current 2 is equal to voltage over resistor 2, which is voltage is 8 over 12. So 80 divided by 12, I'm getting 0.66, which is, if I round it off to one decimal place, this is 0.7 amps, which simply means that in this loop 0.7 amps was there. Then for this one 1.3 amps was there. So if you get 1.3 plus 0.7, you still get the same total of current, which is 2 amps. So make sure that you are able to find the total current. Okay, we'll move on to question number 3. Figure B8.1 below shows a circuit diagram with a lamp connected to a 12 volts battery. Right, so we have the first question where we are told to calculate the charge passing through the battery in 2 minutes. So it's very important to understand the data that you are given. So in our case, we have 0.5 as our current, 12 as our voltage, then we also have time in minutes. So what is the symbol for charge? That is capital letter Q. Then the formula is you get the current then you multiply by time. Now one condition here is make sure that time is given in seconds. Now what are we supposed to do? Since our time is given in minutes, we need to change into seconds. So it's 1 minute is equal to 60 seconds. So now what of 60 minutes? So 60 minutes is equal to x. So this is same as to change from minutes to second. You just have to multiply by 60. So since here we have 2 minutes, let me just get rid of this. So 2 times 60 will give us 120. We have minute, second. So I'm just trying to show you the workings, but the concept is simple. To change from minutes to seconds, just get the given number, then you multiply by 60, then you have your answers. So 2 times 60 is 120 seconds. So this is now the time that I'm going to substitute where t is. So q is equal to, we have current is 0.5. Then multiply by 120, which is current is equal to, so what is 0.5 times 120? Same as the half of 120 is 60. The units for charge are coulombs. Then we can move on to question B. So how much energy, here we want energy, is transferred by the battery. So energy is given by, so we can say voltage times the charge, which is, what is our voltage is 12. Then what is our charge? Charge is 60. So what is 60 multiplied by 12? So I'm getting 720 joules. Or if want, we can also say energy is equal to voltage. What is charge? Charge is equal to VIT. So where there is charge, we can put IT. So this is also the formula for energy. So voltage is 12, current is 0.5, time is 120. So if we can punch 12 times 120 times 0.5, I'm getting 720 joules. So this is it. See, we are getting the same final answer. So it depends on what you are given. So the data that you are given can help you to identify the formula that you have to use at that moment. So now let's move on to question C. Question C, we just want to calculate now resistance of the lamp. So here you just have now to use the Ohm's law. Resistance is equal to voltage divided by current. So V is 12 volts over current is 0.5. Now I want you to see the simple calculation. If you are multiplying a number by 0.5, the answer is just the half of that number. For example, 0.5 120, the answer gave us 60. Now what if you have a number dividing by 0.5? You just have to double that number. So this is same as 12 multiplied by 2, which is giving us 24 ohms. So that's a simple calculation that I wanted to share with you guys. Right, so we move on to a different question. So this one is where you are given a graph, or at times the questions that comes after these graphs can be given also in case you are given a question where you're taught to graph, then after that. So the concept is simple. Whether the graph has been plotted for you or you've done it yourself, the concept is still simple. So I taught the diagram. The following diagram shows a graph of voltage against current. So voltage is in the y-axis, current is in the x-axis. Right, so here, as long as the line is not straight, then this conductor did not obey the Ohm's law. So remember, for Ohm's law to be obeyed, we need to have a linear line. We need to have a straight line, right? Now let's look at the first question. So the first question is, what is the maximum, like the maximum current through the conductor? So the maximum, I'm going to look at where this line is ending. So this is the line, that's the highest point of the line. Then I'm going to draw a dotted line going into the x-axis, because in the x-axis, that's where we are getting our current. So what is the highest number point at this point? We have 3 amps. So that is the answer for number 1, 3 amps. So the picture here is that you just need to follow the line. The last point of the line gives you the final answer. Then we move on to question B. Calculate the resistance of the conductor when the current was 1 amp. So what is the formula for resistance? So we're going to use the Ohm's law. Resistance is equal to voltage divided by current. So remember, current is given 1 amp, but voltage is not given. Since we are given a graph, we need to use the current to find the voltage. So let's go in the x-axis. So we go where 1 is, then we do this. Upon touching this, then we turn 90 degrees into the y-axis. So we can see that if this is 2 and this is 0, the average of the two is just 1. So this simply means that there was a 1. So the number at which the dotted line is cutting the y-axis is our voltage. So when current was 1 amp, voltage was also 1. Then what was the resistance? The resistance will be 1 over 1, which is giving us also 1 ohm. Now let's go to question C. Calculate the power in the conductor when the voltage was at 6 volts. So what is the formula for power? So power is given by voltage multiplied by current. So this is the answer for B. Then this is answer for C. So voltage is given 6 volts. Now do we have current? No, we don't have current. So let's look at where our 6 volts is. So 6 volts is at this point. So if I draw a parallel line to the x-axis, I'm reaching at the curve here. Then if I go down, the current is 3. So when voltage is 6, current is 3. So if we multiply the two, we get 18. The units for power are watts. So as you can see, is simple. So as you prepare for your exams, please feel free to go through this video. Thanks for watching.